All right, so I'm gonna give you an equation to solve. So let's say I had 3 b to the 4th equals, I don't know, 7. And you want to solve for b. First, you divide both sides by 3. Then you take out your trusty calculator. There it is. Do 7 divided by 3. I mean, I know what it is, but I'm going to write it anyway. So you get b to the 4th equals 2.33. Now you might be thinking, why are we going to do this? This is how we're going to solve for the rate of change in our word problems that we're going to do in a minute. So the question is, how do you get rid of the 4th power? You're going to have like b to the 3rd, b to the 5th, b to the 6th. Once you get to this point, you have to get b by itself. So whatever number is here, you're going to have to do the root of that. So this is the 4th power. The opposite of the 4th power would be the 4th root. If this had been b to the 3rd, you would do cube root. If this was b squared, you would do square root, right? I mean, you guys already know that. Like if it was b squared, you would take the square root of both sides. If it was b to the 3rd, you take the cube root of both sides. To get rid of b 4th, I have to do the 1/4 root of both sides. So I have to take the 4th root. So now really quick, let's make our switch to the calculator. I mean, look, this is what you're going to do. So you're going to take 2.33. You know, it's safe to do a couple of them. Do the power. Now be very careful. Put parentheses and put 1/4. I need to do the 1/4 power. Sometimes I might do the 1/3 power, whatever, and then hit enter. So I get 1.235. 1.235. 1.235. So this would be the b in that formula that I was showing you in the class notes. This would be your rate of growth. This is bigger than 1. This would be a rate of growth. If this number were less than 1, that would be a rate of decay. All right, so this is something you'll do in the midst of the problem. I start off with something 30. It's growing at a rate of 5%. If it's above 1, that means it's growing. So I started with 30, and then I ended up with 110. I want to know how long it took me to go from 30 to 110. So the first thing you got to do is you got to divide that 30 away. I mean, my goal is to solve for t. So the $1 million question is going to be, how on earth do I get that t out of the power and into the front? So now look, I got to do 110 divided by 30. There's no reason to share the screen and show you that. So again, 3.66666. Let's just say 667, right? It repeats forever in no pattern. Now, how do you get that t from the power into the front? I paused for a moment to ask everybody how to get that t out of the power, and someone told me to do the log of both sides and then use the logarithm property to move the t into the front. Remember, that was a property of logarithms. When you do log of something to a power, I can take that power and move it into the front as a product. And now I'm going to be good. Let me finish writing this side. So you have log 1.05 times t. On the other side, I have the log of 3.667. Now I'm going to divide this one away over to there. I want to save myself a little bit of writing here. So you get 3. And then you have to do log, divide that by log 105. So you divide whatever you started with away. So you're here. You take the log of both sides, move the t into the front, divide this dude over to there. So he's underneath. And then do this computation, whatever it comes out to. I'm going to do it on the calculator, and then I'm going to write the answer. So I did the computation. I got, can't see it, 26.63. Now, what the hell does that number represent? Well, if I said you started off with 30 bacteria and it grew to 110, and I want to know how long it took this is how long it took. It might be hour, you know, depending on what they told you. They might have told you hours, they might have told you days, they might have told you weeks, months, whatever. So, you know, this would be 26 hours or it would be 26 days, whatever it is. But this is the amount of time that it took you to go from 30 to 110. So if something was growing at a rate of 5% and it started at 30, after 26 hours, say, or 26 days, it would grow to 110. All right, so the word problem, we have 80 grams of uranium, all right, and it's starting to decay. It's radioactive, so it decays. It decays at a rate of 2.5% per hour. So I want to know how much is left after 8 hours. I also want to know what time, how long it will take for me to get down to 30 from 80. Before I can do any of that, I have to do this. I need a function. I need a function to plug things into. This is a function of time, all right? The thing is decaying over time. So first, I have to put the C. Now, what is the C? The C is the initial amount. So I'm going to fill this in as I go. So the C is 80 because it says you start off with 80 grams. So this is 80. Now I need the B. So you can say, oh, it's 2.5. No, it's not 2.5. It is decaying at a rate of 2.5%. So the rate of decay would be 0.025. Again, you can take out the calculator. Just take 2.5, divide it by 100. Now, the B, I already told you, to figure out the B in the class notes, it says you either add or subtract whatever the rate of growth or decay is. B is the rate of overall rate of change. Since I am decaying, I need to subtract 0.025. Okay, so now if you need to do it on the calculator, then you do it on the calculator. You take 1 minus 0.025, and you get 975. So this is 0.975. That's your B. All right, so I'm going to put that up there. So 0.975 T. This is my function for this one specific problem. This will not work for any other question. This works for something that starts with 80 grams and is decaying at a rate of 2.5%. If this percentage is less than 1, that means it is decaying. If this number is greater than 1, that means it is growing. This is not growing. It is decaying. It is shrinking. So now that I have my function, every time I plug in a T, like if I want to know how much is left after 8 hours. So my T, so to do part A is really easy. I'm asking you to do F of 8. I mean, we did this to death in the beginning of the semester. We plugged numbers into the function. I'm going to plug 8 in for T. And I'm going to just compute it. And this I will share the screen and show you on the calculator. Now remember, this is super important. You cannot hop the fence with the power on. You must make sure you do this part first, then multiply it by 80. So I'm going to share to the calculator. I'll clear it out. So I have 0.975. That, whoops, delete one. That was my, all right, it doesn't want to do it. Okay, 0.975. That's my rate of decay. So raised to the 8th power, because it's gonna, I want to know what it's going to be after 8 hours. Hit enter, so you get this weird ass thing. Multiply it by 80. It's lagging on me. Times, why wouldn't it do it? 80. Okay. My calculator stopped working. So times it by 80. I'm going to have to do it on my calculator now. All right, so I was trying to do it by sharing the screen. Unfortunately, it didn't work. My calculator froze on me, so I'll just do it by hand. I did 0.975 to the 8th power, and I got like 0.81665, blah, 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 blah. So you get all of those numbers. Probably going to look horrible. And then I just multiply that by 80. This is where the calculator on the screen I was sharing crashed. So I get 65.33. So my radioactive substance, uranium, started off at 80. After 8 hours, it decayed down to 65.33. Now, I just want to point one thing out. If we were talking about people, or we were talking about ducks in a pond, you know, the population of ducks in a pond is decreasing by 2.5% per year. How many ducks are left? You wouldn't write 65.33, all right? But since I'm talking about a radioactive substance, it makes sense to put that 0.33 there. So if you're talking about the population of a town, this doesn't make sense. So, but it makes sense in this context. So I'm going to leave that there. All right, now we're going to do the second part. Okay, so for part B, at what time? Now, this time I'm trying to figure out, I'm giving you this. What is this? This is the amount that you have after a given time. So when I plugged in 8, I got, 60, whatever the hell it was, 65. So this is an amount. So I want to know what time you're going to have 30. So I'm basically replacing this with 30. But I'm going to put it on the other side because it looks a little weird this way. So this side doesn't change. You start off with 80. 975 is your rate of decay. This is the rate of change. And I want to know when I'm going to be down to 30. So you set your function equal to 30 because this is what I want to know. So now I'm going to divide both sides by 80. I need to get this alone. This is why I showed you the thing before. So you have 0.975 T. You got to do 30 divided by 80 on the calculator. And after my calculator just crashed on me when I shared the screen, I'm not doing it anymore. Now, remember what I said from here. You're solving for T. So I need to get the T out of the power and into the front. This is why I did that example in the beginning on the side. I'm going to take the log of both sides, and I am going to run out of room here. So I'm going to cheat a little. Well, maybe I won't. I want to show you all the steps you have to write, because I'm not going to let you skip all of these steps. The T goes into the front. Here's where I'm going to run out of room. So I'm just going to write it over there. So take the log of both sides. Why do I do that? I do that so I can use the log property to pull the T into the front. Once you get the T out of the power, now I could solve for it. The whole goal is to solve for T. You can't do that when it's an exponent. That's why the logarithm property is so valuable. Now I'm going to divide this guy over to there. And that's what T is going to be. So T is going to be log. When you write this for me, don't skip this. Make sure you show me all of the steps that you did so that I know that you did it. Now, again, I'd share the screen, but oh well. My calculator decided it doesn't want to work today. So I do log 375 divided by log 0.975. This is what you're going to do. I got 38.74. Now take a second to think if it makes sense. 38 hours. I know that after 8 hours, it was down to around 65. It started off at 80. So, that's not a lot. After 8 hours, you only lost 15 grams of it. So, for you to go all the way down to 30, this makes sense. If this answer had been like 2,000, it's not going to take 2,000 hours for it to go that far. Also, if I got an answer here of like 6, like let's say I had T equals 6. How the hell would that work? After 8 hours, you're down to 65 grams. But somehow after 6 hours, you'd be down to 30 grams. This wouldn't make sense. This answer has to be, at least triple this. And, it's more. So it kind of fits and it makes sense. And since we're talking about time, 0.74 is okay here. So you can leave it like that. Also, okay, so second problem. A town starts off with an initial zombie population of 175. As the zombies bite people, they turn. So, the population of zombies is going to grow to 315 after 5 hours. The question is how many you'll have after 12 hours. I can't do any of this without my function. So you're going to put f of t equals c times bt. What is c? C is the initial amount. This is the amount that you start with. In my example here, it's going to be 175. Now, every book uses a different letter. Some books call that A. They all use a different notation, all right? Most of them use the B, though. Some books put an X here. They do f of x. I don't think f of x makes sense here. We're talking about time. So I think it makes sense. Most books I've seen use the t for time. I need my b. But this time, they didn't tell me what rate it's growing at. They just told me that after 5 hours, it's going to be 315. So they told me that when the time is 5, so I know I start with 175. After 5 hours, right, t is 5, it's going to grow to 315. So you see how I made an equation? This is, I'm not even answering A or B right now. I am doing this to figure out my function. Then I can answer A and B. So I have to do this on the side. I need to know my B because they didn't give it to me. They didn't say it's growing at, 3%. I'd be able to figure out the B. But they did tell me that after 5 hours, it's up to 315. So now I'm going to divide both sides by 175. So you get d to the 5th. So you're going to do 315, which is what it grows to. Divide it by what it started with, which is 175. So I get 1.8. Now, how do you solve for b? I showed you this in the very beginning. I need to do 1.8 to the 1/5 power. Now be very careful when you do it on the calculator. Put parentheses. I would share the screen and show you on my calculator, but my calculator already crashed on me once and I'm not giving it a chance to do it again. So I'm going to put 1.8 into my calculator. I'm going to raise it. I'm going to put parentheses and do 1 divided by 5. And I get, now I'm going to go crazy here. I get 1.1247. You do not, under any circumstances, I will say this several times, you do not want to round this less than 4. The more you round this, the less accurate your answers are going to be. If you just wrote 1.12, your answers are going to be dramatically different than mine. I'm going to even show you how different they'll be. So this is the rate you want to use. You do not round this to 1, 2, 5. 4 places minimum, okay? The next number there is a 4. So that's going to be my B. So I'm going to come back up here and put it there. So 1.1247 T. All right, all that work just to find the rate of growth, the rate of change, the B. All right, now I can answer A. A said how many zombies after 12 hours? That's f of 12. So put 12 where the t is and just bang it out. I want to show you how different this is going to be if I rounded this. So take this number, again, raise it to the 12th power, and then multiply it by 175. When I do that, I get 717. Now, I get 717.2. Now, you can make the argument that you can have 0.2 of a zombie, right? I mean, you can have a zombie with like 2 arms and nothing below his chest. Actually, that wouldn't be 0.2. Maybe you have like a couple of zombie legs walking around with no body, whatever. But this is what I get. Now, just out of curiosity, I'm gonna round and see. I'm going to do 1.12 to the 12th and multiply it by 175 just to show you how different of an answer I get. I just did 1.12 to the 12th and I multiplied it by 175 and I got 681. There is a huge difference between $681 or zombies and $717 or zombies. I mean, if you're thinking about money, this is not the same amount of money. And it's certainly not the same amount of zombies. So the more that the more places you go, the more accurate you will be. The more you round, the less accurate. If you gave me this answer on a test, this is not, it's going to tell you on the exam, round to 4 places to be more accurate. If you decide not to, then your answer is not going to match my answer. It's not even going to be close. You know, if you got 718 or 716, that's good enough. But 681 is certainly not close to what I got. Okay, now I'm going to do the next one. So I erased A, and we're going to do B. So at what time T, will there be 1400? I made this straight mark by accident. So basically just set this equal to 1400 and solve for T. So take your original function, set it equal to 1400. I mean, I did this in the class notes. I mean, it's there. I'll show you after. And then solve for T. Divide away the number in the front, always. Actually do that division. Do 1400 divided by 175. It comes out to 8. Well, that's nice. That's by design. So there's an 8 there. Now take the log of both sides. Why are we doing that? We have to get the T into the front. And then you divide. Again, just so I don't have to worry about running out of space here. My 8 looks funky. Divide this over to there, and that's the T. So T is going to be log 8. You guys have your calculator. You can do it with me. Make sure 1.1247. 1.1247. Now divide it away. And then, you know, we'll decide if the answer is actually stupid or it makes sense. Log 8 divided by log 1.1247. I'm doing the same crap you guys have to do. I don't know the answers. I never work these out ahead of time deliberately. So I got 17.694. So we can make it 17.7. So this is how many hours it would take. So that kind of makes sense. After 12 hours, I think it was 771. So, and it, you know, it's growing at a good rate. This is growing at like 12.5%. This is a huge growth rate. So it is growing pretty fast. As more time goes by, it's going to, that's the whole point of exponential growth. It grows quickly. So this sounds about right to me. Certainly it can't be less than 12. I mean, after 12 hours, we had like 771 or whatever it was. No, it was 717, wasn't it? Yeah, I forget. I should have wrote it down. So, you know, after another 5 hours, it grew, it almost doubled from that. So that's the point with this growth rate. It's exponential. It grows pretty quickly. All right, so that's the last one.